I warm welcome everyone to the session 3 of day 2 of ATAL FDP Internet of Things. In the session, we have expert Dr. N. Amuda from Assistant Professor, Department of EEE, Nalanda College of Engineering, Chandi, Bihar. She has completed BE EEE in Government College of Engineering, Salem, and ME in Power Systems in Tyagaraja College of Engineering, and has pursued her PhD in IIT in Power System Engineering under Wind Energy Specialization. We are glad to have her in this session, and the topic she will be presenting will be about interaction of protective relays with smart grids using IoT technologies. I now hand over the session to Dr. N. Amuda to enrich her knowledge and enlighten us with the smart grid and IoT technologies. Thank you, ma'am, for coming. Thank you, ma'am.
Thank you, Professor Anita. Good morning, everyone. Or actually, good afternoon, everyone. And I'm Dr. Amuda, introduced by Professor Anita. First of all, I would like to thank Professor Jagadish Kumar as well as the management of Sri Ram Institute of Technology for giving me this opportunity to talk with you on. Okay, so let me go with the presentation now. Screen is visible now.
No, ma'am, your screen is not visible, ma'am.
Now,
Yes, ma'am, the screen is visible now.
okay. Thank you, ma'am. So let me start the presentation, and today's topic is interaction of protective relay with smart grid using IoT technology. This slide was prepared by myself as well as my PI, Mrs. Kumda, and this lecture was part of a project. The project was funded by the NPIU, Machadi, and so let me go into the presentation now. These are out of my only 3 topics will be covered in this one. One is the protection system in case of microgrid environment. And next one is the IEC 61850 standard, which we are going to use it in our microgrids as well as for communicating with the others. And since we are talking with the IoT devices, we will be dealing with this standard. And next is the low cost solution, because implementing this 61850 maybe we can find it may be difficult for a cost effective type of distribution generators. So this will be like a low cost solutions. Actually, that was the aim of this project also. So first, let me go with this conventional grid. So what is a conventional grid? A conventional utility grid, which is a system which distributes the electricity generated at the generating station to the consumer, and the consumers are usually present at the load centers located far away from this generating stations, right? So that we will all know that is a utility, conventional utility grid. Okay, and the power production, power coordinating system, whatever found in this conventional grid is like a zonal production, which we have studied in our BTech levels also. So we will be using some relay, which is a sensing device, which detects the which what is the function of the relay? It should detect the fault or it should detect the abnormal conditions against this normal conditions, and once it is found any abnormalities or the faulted condition, it has to initiate the action. Okay, how it is going to initiate the action? It is based on the relay characteristics, right? So the fault which in case of the conventional grid usually happens parallelly, right? So the number of relays present there, it depends on the economics, right? So because the relay production system, it is very high cost, and so the redundancy like installing more number of relays, it is of not that much economical, right? So okay, so next thing is like the relay which is going to be employed in this conventional grid. It should have the properties of reliability, fast operation, sensitivity, and selectivity in identifying a particular fault location as well as in identifying the fault itself, like characterizing the fault itself. It needs the selectivity, right? Selectivity and as well as the sensitivity, high sensitivity as well as the selectivity, right? So based on this relay characteristic, predetermined characteristic, it is trying to give the initiation action to this circuit breakers, right? Okay. So how these production system of conventional, it is based on these following parameters. Usually, if it is the relay system will be of such a way that it depends on one parameter or one value of the particular electrical value of that particular system, right? So it can be either voltage relay, under voltage, or over voltage relay, or over current relay, impedance relay, frequency, under frequency, or over frequency relays, like that, right? So if you are taking a over current relay, it is going to sense only a particular value of current, and then it is going to initiate the action, right? It is going to identify like whether during the fault conditions there will be excess of current will be there. So the current over current relay is going to detect that over excess of current, and then it is going to activate that particular relay, right? So a single relay will be depending on either one of these parameters, and it is going to act accordingly, right? So in this case, the reliability of the fault detection as well as the fault clearance will be like in question, right? Because it is going to depend on particular values only. But it still works in the conventional system because it has a predetermined set of settings and well-defined characteristics of that particular relay. So it was working fine with the conventional relay, right? Conventional production system, right? But but due to this power losses observed during this transmission from generating station to the consumers, what this large consumers does is like these are the consumers, large consumers. What they have done is like they try to have a small renewable sources nearby so that it can supply the ancillary loads, right? It is they are trying to have a small distributed generators nearby so that it can supply the ancillary loads and ancillary loads of the utility grids, right? And that way they can reduce the cost of some of the electricity cost. They can reduce it, and sometimes this may be if there is a fault in this line, then they can use that whatever the renewable energy sources to run their critical loads, right? So they try to form a renewable sources nearby areas, and then they are connecting it. And now, whenever the utility grid is available, the power is sufficient to run this load. So in the cases what the excess amount of this distributed generators supplied to the nearby loads, right? So by this way, they are forming some microgrid among themselves, right? So this consumer, along with this DG as well as the nearby loads, they are forming a small local grids, then that is nothing but your microgrid. So the microgrid is defined by the DOE as a controllable loads, because some of these loads are taken by this DG, so it can control that load, whatever available consumer one can be controlled by this DG, right? So this we will call it as a controllable loads. So the Department of Energy, they are defining this microgrid as the infected loads and distributed energy resources within clearly defined electrical boundaries. What is this electrical boundary? Because this DG is going to operate on this consumer or the nearby localities. So there is a well-defined mark of this electrical boundary. So this electrical boundaries we will call it as a microgrid, which is nothing but a controllable loads, right? Controllable loads. Okay. So, like the small microgrids are connected here now. Like here was only one DG is connected the consumer one, but there may be so many other DGs also connected with the consumer one. And similarly, the other consumer two may not. These are the large consumers, right? So they may have the other DGs connected with the local loads. Local loads means these are connected with the distributed lines, right? So this taken from a small grid, right? So slowly microgrid in this utility grid. Okay. Once this utility grid is created by this microgrid, okay, there is a change in the characteristics of the utility grid. Though the utility grid can have this controllable load as an advantage, that because it can schedule it power planning, as well as it can schedule generations as well as load containment well in advance, right? Because of this controllable loads. But when these are connected as a controllable loads, no problem. But during the fault, there is no fault in the utility grid. Okay, suppose in this one. Suppose if there is a fault in this line itself, okay, from the main utility grid itself, there is some problem. Okay, there is some fault here. Okay, the relay present here, what it will do? It will break this. It will show this. Okay, so it will cut short this bus bars, right? It will cut short this bus bar so that it will not be connected to the utility grid. Thereby, it will safeguard this consumer one from the fault created on the grid side, right? Grid side, because of the fault created in this grid side, it should not be affecting this consumer one. So the relay at this point will isolate this bus bar so that the consumer one is protected. Okay, this is the usual case in the conventional grid. Okay, but then suppose this is also one microgrid, right? This is also one microgrid. So, for example, if you are considering this also one microgrid, and this consumer, okay. So there is some part of a critical load which is also connected with this bus bar, okay. Some critical load is connected with this bus bar. Okay, so for example, if you are considering this line is also not available. Okay, so in this case, the supply to this critical load is completely cut off. Right. So because of this fault in this one, because of the operation of this relay, the entire bus bar is getting cut off, and there is no supply to this critical load, right? So there is a imbalance between the power demand as well as the load demand, and because of this, there arises a stability problem also. After that, after the clearance of this fault, and then the resynchronization of this microgrid, utility grid with this grid again becomes a difficult, right? So for that, what the grid is suggesting is, even for the fault available in this part, that is at the utility grid part, the consumer at the other side, or the microgrid which is connected with this line, it should not be cut off, right? It should run for some time. After that, after some time, it may be disconnected. Okay, so it means that it is going to supply some power to this fault, because this DG, it is going to supply some fault current to this fault current, the fault which is available at this grid side. So the DG is going to supply some fault current to this fault, right? So the grid which is asked. Okay. So that part we will call it as a low voltage ride through or fault ride through. Okay. So during the fault conditions, the voltage will be low. Okay, voltage will be low, but because of the low voltage, the microgrid or the distributed generators, which is supplying, which should not be removed. It has to be continued to be operated at least for the few seconds, which is given by the grid. Okay, for example, from T0 to T1. Okay, from T0 to T1, it should not trip. Okay, that is, it should not be disconnected. It has to completely supply the load. Okay, suppose if the voltage is this V3. Okay, suppose the voltage during the fault is V3, it means that the fault is not that much severe, right? So that much severe it is not there, but for this fault, it is expected that the generators would not be disconnected for this much amount of time. From T0 to T3, it should not be disconnected. After that, it can be disconnected. So it means that the generator has to supply the power from T0 to T3. Okay, after that, it can be disconnected. Okay, and this we will call it as a low voltage ride through, and similarly it can be considered for the high voltage ride through. Why this high voltage ride through happens means, after disconnecting, there may be auto reclosing of the relay may happens, right? At the time, and in some cases it is the voltage is moving in such a way that it is moving away, like higher than the determined expected voltage, right? But in that case also, it should not be tripped off. That means that even if it is if the level of high voltage is V5, it still has to be remained connected. Okay, but what is it? This regions and this region, these are the regions where the distributed generators can be disconnected, but the region available in between these high voltage as well as this low voltage curve, it should not be disconnected. Okay. So these two conditions it has to satisfy. Okay. Okay, so with the microgrid added to the conventional grid, the original production coordination, now it has to be like adaptive production coordination. Okay, in earlier cases, the production coordination, it depends only on the characteristics, right? It depends only on the relay characteristics. It depends only on the relay. It is going to sense the abnormal conditions, and based on the relay characteristics, it is going to give the initiation action, right? But here, But here what it has to do, apart from the relay characteristics, even though relay characteristics says that it has to be tripped at this point, okay, as for example, in between T0 to T1, it has to trip, but at the same time, it has to observe the grid code or the LVRT or this FRT. FRT is nothing but the fault right through when the low voltage is assumed as zero. Okay, here at least the voltage is equal to, if the voltage is less than V1, then it can be disconnected. Whereas in the FRT, fault right through capability, it is a zero voltage condition. Even at the zero voltage condition, the distributed generator has to run out, has to supply the power. Okay. And so in adaptive protection, apart from the relay characteristic, it has to obey with the grid code as well as the compliances. What is this grid compliance means? Like, it has to supply power. How much power it has to supply, that will be given by this grid compliances. Okay. So at this much amount of voltage means this much amount of power it has to supply. That both real and reactive power. Okay. That is not the grid compliance. Okay, grid requirements means that it has to compulsory, it has to mandatory, it has to go through it. Grid compliances, it may leave, but with the finality, it can violate the rules. Okay, with the finality, it can violate the rules. Whereas the grid code recommends it has to do it. Okay. So these two characteristics, it will be processed by the relay. After that only it is going to instate the accents. Okay. So nowadays the numerical relays are replaced by this conventional relay, because this numerical relay can process the data between this relay characteristics as well as the grid code as well as the compliances. Okay. That's why apart from the other reasons, the numerical relays are also getting popular because of this. Because of this grid code compliances. Okay, till now, this penetration of microgrid is very less. Okay, but because of the depletions of this renewable sources and the need for the clean energy, it is necessary that we have to we are expecting so many microgrids to be injected into this utility grid in the near future. Okay, even if you are taking a smart city, it means that you will be having small microgrids available here and there. Even our terraces may be given as a terrace as a service. Your terrace may be used by some PV cells. PV cells can be installed over in your terrace, and that can form a microgrid, right? With your neighbors, it can form a microgrid. Okay, so even your terrace can be used as a terrace as a service. Okay, that is expected, right? So with the smart city is going to come, so we are expecting that so many microgrids is going to penetrate into this utility grid. Okay, and this microgrid, it is like consumers as you can imagine that we as the distributed generator owners. Okay, so we are a a middle income group, right? We don't spend much amount on this. We don't invest much on this productions for this microgrid. Okay, so a production, it will take lot of cost, right? So what we will do, we will either replace the PV cells or we will be cut off that particular generations. We are not expected to comply with the grid codes and all. We are not expected to do that things, right? Okay, but we have to follow these grid compliance as well as grid rules. If you are going to have if you are going to be involved in this microgrid, then we have to do that. We have to be involved in that also. Okay. So here also the same thing. This utility grid, the connection with this utility microgrid, there may be some common relay which will be operating this microgrid and utility grid. Okay, whenever there is a fault, it is going to it is expecting that all the microgrids obey this grid code requirements. Okay, grid code requirements it has to obey, but at the same time it is allowing the microgrid to be disconnected at these regions, right? At these regions, it is able to, we can disconnect it. Okay, but some microgrid operators, they are thinking like, if I'm going to supply some power during this period of disconnection, I may be earning a lot. Right? So it means that this grid code, it may be common for the utility grid, but whenever we are having a microgrid, and microgrid like distributed generators as a entity, like a entrepreneur, those who are having this distributed generators, they may think that if you are going to supply at this during this periods, okay, you are going to earn so much, because no one is going to supply. Everyone is trying to disconnect their distributed generators, and we are going to supply the extra loads or critical loads. So we will be getting a high cost. High cost for this for the power generation during this period. Okay, at that case, what it will do, like the tip characteristic, whatever it may change. Some microgrid may have this type of characteristics, and some may have this type of characteristics. For example, this microgrid 1 is going to have this type of characteristics, and microgrid 2 may have this type of characteristics. So obviously, when the load is connected, what we will be looking? We will be looking to connect it with the microgrid 2, right? Because it is going to supply some power during the off period also, right? So the microgrids may have different type of characteristics within it. Okay, so it is expected that the relay, when compared to the conventional relay, if the microgrids are going to penetrate, the relay characteristic, it is not a single characteristic or one or two characteristics. It is going to be a series of characteristics, right? So it has to adapt to the market demands, as well as to the grid demands, as well as it is to be economical also. Okay, it is to be economical also. These three factors, it is going to decide the relay characteristics of your microgrid. Okay, that's why the relay characteristic of microgrid nowadays are getting importance for this, because it is getting a marketable value. Once you are getting a marketable value, automatically the trust for that is increasing, right? Okay. So, see, we can have some different type of trip characteristics, but yeah, since each and every microgrid we can consider as a single entity. Even in the microgrid, we are having so many entities which is going to manage the distributed generators. Okay, because of this, the synchronization with the utility grid may become a problem. Once during the fault, the utility grid, which may be separated from the microgrid, that is, it is going into the islanding mode. Okay, at that time, some relays, some microgrids may, some distributed generators may be supplying some loads. Okay, and some they will be off, right? So the resynchronizing of all these distributed generators will become difficult. Okay, and second thing is second thing is this reverse flow, right? Yeah. Hello. Okay. So the second one is reverse flow fault stripping, in the sense that this is not only dealing with microgrids, it deals with the microgrid with the utility grid. Okay. In the usually this utility grid, the power will be going from the utility grid to this microgrid. It is the usual cases. Okay. In some cases, it may be having a reverse flow also. In that case, it will be difficult for it to detect the fault, right? It is because the grid is not going to supply so much power, right? It is going to have a reverse flow only. Okay. So the fault detection at this case and in this cases also it is difficult. Okay, and next thing is stability. Stability is a major issue in case of this microgrids, because these distributed generators, usually it will be a PV cells. It is connected using this inverters, and next will be like a small gas turbines will be there, diesel generating sets will be there. Okay, but these will be having low inertia to observe the oscillations. Okay, once there is a high resonance type of oscillations available, if it is present in this entire grid, it is going to affect the stability of the entire grid itself, right? So because of this low inertia, there will be frequency deviations will be there, which has to be met out. Okay, and next is this distributed generators. Since it is depends on the weather conditions, it will not having a there is no certain that you can get power from this particular distributed generators today. Okay, here even today now here it is raining, and whereas in Chennai it will be like a very hot, right? So these weather forecast we are able to get it, but we are not able to get an accurate way of weather forecasting, right? So even if there is accurate weather forecasting is there, obtaining those results will be having like which will have a high cost again, and again the distributed generators will not going to operate with that forecast because it is very high. Getting the data is also very high, right? These are some of the difficulties which will be faced by this by the relays when we are connecting in the microgrids, right? So whenever this microgrid penetration is increasing, then the adaptive production coordination becomes adaptive and communicative production coordination. Okay, because why this adaptation? It is adaptation because due to this, it has to adapt to the grid code requirements as well as the relay characteristics. That is why it is adaptive. But what is the communicative? Since this relay it is going to communicate with the nearby microgrids also. It is going to communicate with the nearby microgrids also. Therefore, it is not going to communication means it is not only with the related to the production system alone, right? It is going to come like there will be communication between these two. How much power it is going to supply for this microgrid for how much time? Those informations will also be sent among this microgrid. Based on that only they are going to operate the distributed generators, right? So it is expected that the relay now. It will not function only as a relay, it will function with the other capabilities also. With the marketing data, it has to analyze like other marketing data, it has to analyze, and other requirements, grid code requirements also it has to satisfy, right? And next thing is like in this case, like in our previous conventional power protective relay, we have the independent relay, like some relays which are depending on only one parameters. I told you like it is a overcurrent relay means it depends on one parameter of current itself, right? So if it is under voltage relay, then it depends on the one parameter voltage, right? Here, but in this one, it is going to get so much amount of data from different relays, different sensing or measuring instruments, like it may be from the parameter can be a voltage, current. It can collect all the data because it needs all the data because it has to do the market, right? It has to be remind the market for that it is going to get all these data, right? And so apart from that, it has to do the relay functions also, right? So in the relay what is the function of the relay? It is not limited only to the relay operation alone. It depends on the other requirements also, right? So it has to be data collector, analyzer, and compliance inside the microgrid as well as between the microgrids. Now the microgrid is nothing but the distributed generators as well as your local loads, right? It has to comply with those local needs also as well as between the microgrids also. Okay. So one thing in this case is like every data is measured at some other distance and it is transmitted to this relay. Okay, so now this relay it is not going to operate only with the parameters it is near to its area. Like it is going to operate with the parameters with available at the other ends also, right? So the communication failure which may be appearing like even we are having some because of bad weather, like there may be some interruption in the communications, right? So in that case what happens, like the communication is breaking up, so the relay will stop working, right? In that case, the serious problem, if there is some fault in that one, then it will not be able to detect that fault and the entire system collapse. Okay, so the system has to be built on the production coordinate, conventional production coordinate. After that, it has to have this adaptive layer as well as the communicative layer, right? So it has the modern communication, the modern production system has three layers, right? One is the conventional, and another one is adaptive, another one is the communicative layer. Okay, like even if the communication layer fails, it has to go with the adaptive layer. This adaptive layer is given by this numerical release, right? Even this numerical release phase, at least it has to work with whatever the quantity available with it. It has to work with, right? So it has to depends on the relay characteristics. Okay, so these are some of the modern production systems available in the literatures. This adaptive production relay with the PMU phasor measurement unit they are using, and they are making some, but that is again adaptive. It is not a communicative devices. Okay, and the other three popularly widely used or widely searched for it is like this one: pattern recognition production, multi-agent production, as well as wide area production. Okay, pattern recognition, it will identify the patterns, like how these distributed generators are behaving. Based on that, they will be having some pattern analysis, and from the pattern analysis, they are going to have the characteristics. Okay, but that is less reliable. Okay, and again, another thing is the multi-agent production system. In this one, they are having some different layers. Okay, like the relay part one, it will be considered as one layer, and the substation layer will be considered as another layer, and the system is considered as another layer. Based on that, they will be having some communication between this, and they are applying the protection coordination. Okay. That is about this multi-agent production. And wide area protection, it is again the same thing, like you are protecting an area of like you are covering some large areas, right? So this is a popular one. And nowadays, like I have told you, like the distributed generators, it is not going to be like it is going to available in all it is going to available in all places, right? Like even our middle class people, we are going to have some distributed generators. Okay, but whatever the distributed generators we are available, we are having, we are not going to employ high end technology for the relay alone. Okay, because the fault, it is going to happen sometime. We are not going to spend much for rare occurring events, right? But it is highly necessary, right? Even one breach, it is going to destroy all the grid system itself, right? It is necessary, but we have to, how it can be done with the low cost, we are going to see it. But before that, let us have the standards. Okay, so we are using this communication systems are well developed. Okay, these communication systems are well developed, and we are trying to adopt these communication systems for our relay purpose as well as for other purposes, for other control purposes also. We are trying to adopt it. But how to adapt it? Can we adapt it along, like whatever sending, like converting into bits, and we are sending into the communication layers, and we are going to communicate like that, or how to communicate it? And for that, they are having some standards, right? They are having some standards, because this even this adaptive production relay, that is the numerical productive relay, they are having different processors in it, right? They are going to have different processors in it, and they are going to use different languages for communicating between these devices. So there will be different type of manufacturers, and different specifications are available. It is difficult for us to make the interconnections of these equipments. So there comes the standards. Okay, so the standards are mainly for the interoperability as well as integration of these long of these equipments with the different manufacturers, different specifications. It should not be resource. It has to be long term. Right? If you are making standards, it has to last at least for 50 years. Okay. So because every manufacturers, every vendors, they are going to follow this particular standards, right? So because of that, we can have a cost as well as loss reduction also. Okay. And some of the standards available are this IEC 61850, which is popular nowadays. This is the substation communication standard. We might have studied it in our SCADA. Okay, and actually this standard, it is combining this utility communication architecture. Okay, utility communication architecture as well as some other IECs 60870 as well as IEC 61499. Okay, this deals with the telecommunications, and this deals with the control application. Okay, this is for industrial automation, but this is the standard version. So they are trying to employ this automation, industrial automation, to the 61850s. Okay, apart from that, there are so many other standards also. Okay. So what is the need for this standard? Because like this was taken from this ABB review, and earlier connections, there were like RS-232 cable was there, right? For each and every device, we have to connect so many cables, and we have to make it operability, right? So suppose if one is not working, then the entire system may go off. Like there is copper cables only, right? Because of this copper cables, there may be some losses also will be there. Okay, and some miscommunications will also be there, right? To avoid that, they are using the fiber optics cable for communications. But each and every device, it was having its own way of communication with this substations. And now what they are trying to do is they are trying to replace this part. Okay, they are replacing this part. Already they have made with the standard IEC 61850. Instead of proprietary, they are making as a open source. Like it can be easily adopted by anyone. Okay, and apart from that, this is like a communication between this sensors as well as that particular system, right? So for that, they are trying to replace this portion also by this IEC 61850, so that easier communication can be obtained. This it can be imagined like we can have like distributed generators, separate distributed generators. Instead of connecting through different communication like lines like copper cables, instead of that, we are having some common single serial link communication which can be used. Okay, and with the same communication, like once it is giving a signal, let's suppose if this system is giving signal, then the same signal can be given to this micro grids also, like distributed grids also, and it can easily communicate with this devices also. That is the main reason for imposing these standards. Okay, thereby the communication, thereby the production will becomes easy, right? Even the communication phase, at least we can have the other way of protecting the devices. Okay, so this is the standard way of representing the data in the 61850. So the each and every equipment, it was divided into small units. Okay, first they are mentioning like, so for this one, this is our productive relay. Okay, productive relay, it is a numerical relay, right? So numerical relay, it is going to communicate with the circuit breakers as well as some other measurements. It is measuring instruments. It is sensing instruments, right? It is going to sense a voltage as well as current. So it is going to take the information from these things. So they are making this relay as a logical device, and with the logical device only they are going to communicate. Okay, with the logical device they are going to communicate, because this is the sensing device and this is going to be our activating devices, right? But the activating devices is also controlled through this sensing device itself, right? Because of this numerical production, we are going to involve that one. Okay, and this logical nodes is again break into two small data objects, and data objects which can, the data objects is nothing but your position of this circuit breakers as well as their current values. Okay, these we will call it as a data attributes. Okay, so this attributes the data structure of this 61850. It will be in this form. First one, it will identify the logical device, and next one it will going to identify the logical nodes, and then it is going to identify which type of data. Even the circuit breaker, it may have other data also, right? Even the oil temperature data also it may have, right? That informations will be sent as a data. Okay, and data attributes, whether it is high, low, or whether it is like a 1, 0, 1, like that, it may have, right? So it is usually communicated in this relay 1, XCBR for the logical nodes, and data position. For example, here it is a position, and this is attributes. It is a status value. Okay. So we are having a large number of data. Like we are, for example, if you are taking a relay itself, it is not going to sense only the voltage now. It is going to sense the different parameters, right? Current, voltage, power, even temperature of some devices, everything, right? So this set of data, how it is going to be communicated? It is going to communicated as a data abstract service. It is going to have some abstract, and then it is going to communicate it. Okay. So in case of a microcontroller or microprocessor, we may be having these three communications, three data only: read data, write data, as well as control data, right? Whereas in this case of IEC 61850, we are having the other data also, data types also, right? So apart from the read data, write data, control data, we are having report data. Report means it will report the events. Whatever the events happening in that particular model, it is going to report it. Okay, logging as well as read the data model itself, file transfer, goose, and sample value. This goose and sample value are the important messaging service of this relay. Okay. So in this case, when a particular circuit breaker needs to be operated, the signal will be given from the server to these control switches. After that, it is going to the circuit breaker. It will give the select commands. Once it is getting acknowledged, it is again sent back. After that, after getting acknowledgement, it is going to give an operate signal. Once it will acknowledge the operate signal also. Once it is getting operate signal acknowledged, it is going to send that it has started its operation. And after opening, it is going to give the new position also to this server, right? So there is a complete information of this. Whereas in conventional production relay, there is no complete information. So it is going to operate based on its value available with the characteristics as well as with the nearby values only. It is going to operate, right? Whereas here the server has entire control on it. Whatever the data it is communicated, it is have the authentication also. Even this select fails, or if it is not acknowledging back, it can directly send the signal to the other circuit breakers, right, to open it. So the communication is making the operation to be faster enough. And this is the communication stack. The communication, whatever the mobile communication we are using, it usually deals with this 7 ISO OSI stack layers. Okay, whereas here, apart from this 7 layers, based on like application and the application layer only, we are going to have all the models as well as the other data. We are going to build on that only. But in case of emergency, that is trip signal, if you are going to give it, it's an emergency condition, right? In case of emergency condition, it will be communicated in terms of goose language. Okay, it is communicated in the goose language as well as the sample value or the particular point at the particular time will be selected and is directly sent to this second layer, data link layer as well as physical layer. It will bypass all these layers, TCP, IP. It will bypass everything so that the time it can be saved, right? Instead of traveling all these layers, it can directly go through this data link layer as well as physical layers, so that the time in making some alarms or with making some tripping actions, get the time is getting reduced, right? Like we have a quick access to those emergency situations, right? So this is the in my computer language. Similar, we are having the C as well as C++, some different language we are using, right? So here we have the subscription configuration language, which is used to communicate between these IED layers, IED devices with other IED devices, okay, along with this substation layer, okay. And this substation configuration language, it is based on this XML based languages, okay. So it is written in the XML and then it is sent back. And these are the file types. I'm not going much details into this. Okay, so till now we have seen about this 61850. Okay, you can see that it is a long process, right? So implementing this may take a lot of time, as well as it is difficult for us to understand also, right? So at the initial stage, what we can do is we can have some in this project, what we are aiming is, like, there is a relay. The relay has to be communicated, but at the same time, before communication, it has to do all the analysis, right? It has to do some analysis, like for example, like this analysis, it has to be done, right? It has to be done. After that only it is going to give the initiation action. Instead of this one, there will be some numerical relay which can do that, but at the same time, it is not going to store any. We cannot store much information, right? So it is going to work on a cloud only. Okay. So in that case, there are so many small processors like a BeagleBone and Raspberry Pis and some small processors, microcontrollers are available. Those microcontrollers are available. We are trying to interface this this Raspberry Pi and BeagleBones between this relay as well as this numerical relay as well as this substation. Okay. For that, actually, we cannot go with this. But we have to follow this goods as well as the sampled value. Everything we have to follow, right? Within a particular microseconds, we have to communicate with that, right? So for that, actually, we found one software that is 4diag4t, 4diag4t. Okay, so that function, it is actually, this function is depends on this IEC 61499. Okay, 61499, which deals with the industrial automation. The same is used here. Okay, but as a software, instead of doing all these things by ourselves, we are just moving as a block and then we are trying to solve it. Okay, and we are trying to communicate it. Okay, and here actually in this IEC 4199, what we are doing is this control systems, which is divided into small function blocks, and the communication between these two function blocks will determine this is going to determine the control system of the control system of the particular process. Okay, so in this code diag also, what they are doing is they are taking the sensing input as they are the inputs sense. The inputs from the sensors are taken and it is given to the control system function blocks. After that, it is given to this. After this, it is given to this internet and whatever the analysis, whatever the trip signal it has to give. It has to give. After that, it is communicated and it is going to give the output. Okay, so this is the 4diag framework. The physical data and inputs will be in this layer, and this runtime environment is nothing but your control system. control system, and it is going to give it. It is going to be communicated with the substation here. Okay, here it is a distributed industry solution because we are using this IEC 6.499. And these are some components. One is IDE, another one is RTE. I have worked with this IDE only. And this IDE, it works on this Windows, Linux, and other operating systems also. And the development boards, it is offering from wide range of developing boards, BeagleBones, Raspberry Pi, ARM, and ARM7 and PLC. And it also supports some different communication networks. Even it supports Ethernet, RST32, Modbus, everything it supports. So this is the application model. In application model, each and every small control functions are given as a block, as a function block. Okay, in the function block itself, it will have this event as well as the data processing. It will have two different functions. One is the event generation, another one is the data processing. Okay, so these are like a system model. This is application model, means like with a small function block it is doing, but here it is a system itself, right? It is a system itself. And in the distributed model, what it will do, like the same small function block which is going to be available with the device, the same will be given to this device too also. Okay, instead of creating another FB1, we can directly make it to communicate. So, for example, this is available in the this was available in the literature also. This is provided by Thomas Strasser, who worked on this tap changer algorithm algorithm in the Ford diag. We have also tried it, and I can play the movie which we have recorded. First, we are selecting the new system, and we are giving the name of the system. The same name will be coming here. This is application layer. And once the application window is open, then you can see that there is application window, system configurations, as well as the type library is there. In the type library, you can have some different devices. You can just drag and place it over there. Okay. So in this one, they have given some server. Server means it is going to take data from the substations. You can imagine that the data are taken from the substations. Okay. Like after that, we are trying to convert to the suitable values. Okay, and this actually we are trying to implement this greater than less than +1 -1 using this one. It's a tap changer, right? Tap changer. Based on the condition, it is going to change the tap. Okay. So after having all the blocks, connections are given for the data as well as the event. Okay, event. Once it is given, you can connect this control function with this Raspberry Pi or any other thing. Like we have chosen this Raspberry Pi, but we can have a BeagleBones and other processors also available. So it is communicating with this Raspberry Pi through this 61499. Okay, the communication. So we can interface these two. And you can see the color changes. Like initially it was white. After it was interfaced with this Raspberry Pi of color is like yellow. So the same yellow is available here. And similarly, we can use the different other processors also, like small equipment, low cost equipments. We can use it. And once it is there, then we can have a deploy. Like once it is there, there will be some deployment in this run option. like once that Raspberry Pi is connected, then it can be easily communicated with those applications. Okay. So this is the application. We tried it. It was working, and we thank MHRD. Now it is a Ministry of Education, World Bank, NPIU, Nalanda College of Engineering, and DST, Bihar for supporting this project. And we thank the AICT and Sri Sai Ram Institute of Technology for providing me the opportunity to present here. I think I have completed my session.
Participants, if
Any questions if you are having, I can answer. Yeah, surely I will start the slide. Which meet after this. Audio is not clear.
so any questions from audience side? Ma'am, then we can wind up the session, ma'am.
Okay, sir. Thank you. Thank you very much.
Vote of thanks.
Thank you, ma'am. Thank you for handling this session in a very detailed manner. We learned a lot about the different types of
Sir, shall I leave now?
Thank you, ma'am. Thank you for handling the session in a very useful manner, ma'am. We learned a lot about every IoT techniques, ma'am. Thank you for sharing your knowledge, ma'am. We had a great time. Thank you, ma'am.
Yeah, thank you, Professor Anita. But the voice may be like I have seen that there are issue with my voice, audio, because it is raining here. Maybe because of that, voice may not be audible now. Audible, I think.
It's okay, ma'am. Your voice was audible enough, ma'am.
Okay. Thank you.
Thank you, ma'am. Thanks a lot, ma'am. Thank you, participants, for being in today's session. I'll be sharing you the feedback link. You can fill the feedback form. It will be open for about 1 to 2 hours. If you have any other doubts or clarification, you can put it in the chat box. Thank you for your patience. Thank you.